Week 5. Diodes. Eugene E. Mikoff, College of William and Mary, Week 5. Material was everything when capacitor, inductor, transformer, Kirchhoff law, Thievian theorem, voltage, fire filter, complex impedancy, source impedancy. Shows anode amps, anode cathode, reverse region, forward region, negative and 0. Anode on the left, cathode on the right. Pure semiconductors, and then shows silicone. Semiconductor doping, silicone GE and GA. Pure semiconductor PD, positive dope, negative dope. Non-bias and voltage and positive negative junction, negative in voltage to the positive, reverse bias. Positive, no positive negative junction, no bias, negative to positive, negative positive, negative positive, forward bias, negative positive, forward bias. Amperes anode cathode, amperes times volts equals ample output, and voltage of over to the volts to the number of the voltage T1. Saturation current is divided by 1 nanoampere thermal voltage emission coefficient. Anode cathode parameters, reversory region, forward region. Alright, voltage, positive, negative diode, positive, negative jumping, open voltage. Bit more realistic diode, resistor R1, resistor R, resistor F. Circuit protection, diodes application, circuit protection, rectification, current gate, half-wave rectifier, full-wave rectifier, power supplies, frequency manipulation, frequency multipliers and mixers, and more, voltage clamps, lighting, emitter diodes, photodiodes. Half-wave rectifier shows as voltage input going to the diode to the resistor voltage output. Shows the cosine in red and the voltage output in times. And then it shows a full wave rectifier, voltage in, current transformer, grounded 4-way Wheatstone, and diodes to a resistor voltage output. That's a full wave rectifier. Cosine in green, orange, red, voltage output in T. So we have a full wave rectifier filtered. That means we've added a capacitor and resistor. Full wave rectifier frequency doubler. 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 Full wave frequency adder shows the 2 inputs on a frequency and then Wheatstone bridge resistant load to the voltage output and Alright, Chapter 5, Diodes. This week we will explore with another new passive circuit element of the diode. We'll explore some of the diode applications, including conversion of the AC signal to a signal that never changes polarity to beyond with the making of a real DC signal. We'll take a few more tools, include a low-pass filter. Theory. Nonlinear device. The diode is the first nonlinear circuit element. Nonlinear element passes a current non-proportional to the voltage across that does not obey the Ohm's law. Note that through the small change of the voltage across the diode will still generate a small change in its current. Thus, the change in voltage is small enough that the change in current will be proportional to small voltage change. Even circuits with diodes can be used in theory to model some deviations from a quiescent or normal condition of circuit. Diodes, when it's important for the component of the DC power supply to convert an alternating current to the direct current. Most of the time, we will model a diode as simply one gate current. In most wires, resistor currents are carried exclusively with electrons, which have the negative charge semiconductor silicon-based devices can be used either negative charge carriers, electrons, or positively charged carriers called holes. Depending on what impurities have been added to the silicon, whether it's grown into the crystal, one type of the impurity called the N-negative doping creates the negative carriers, and the other type is called P-doping or positive carriers. In junction, including positive dope and negative dope, silicon makes diode as shown in Figure 5.1 above the electrons. Figure 5.1 shows the holes in the electron recombine, letting current flow. We have the amperes going from right to left and the positive to the negative, and then the holes of electron current cannot flow through the other flow since there is no energy creating holes in an electron, positive going to the left and negative going to the right. Electrons' holes can easily recombine when either the positive and negative junction produce a net current flow from positive to negative. However, the current wants to flow the other direction, so both the electrons move away from the junction. Then the junction will actually open with the switch of the diode, so simply device the remarkable property that they only conduct current in one direction. Diode model current gate. For almost particular purposes, we will treat the diode as a one-way current gate. Always allows 0.6 voltage drop with silicon, 0.2 voltage uranium. Voltage drop of the energy converted with the electrical hole pair of the recombined diodes, making them sometimes line output and showing the direction of the conduct. And accompanying the figure, the diode will conduct the voltage input greater than 0.6 volts. When the diode does conduct an excess voltage drop, shows up across the resistor. In other words, the diode just conducts enough in current so that the amp, such as ampere over the resistance, equal the voltage in minus 0.6 volts. Figure 5.2 shows the diode as a one-way current gate. Diode Model 2 with the Ebers-Moll model. For more complete diode, we would treat the resistance for the diode as the logarithm of voltage applied. With the more complete models shown graphically in Figure 5.3, we note that 0.6 threshold volts approximation for the reasonable voltage shows a reverse bias breakdown region of 75 volts, a reverse bias region, and a forward bias region of 0.6 volts. Typical silicon divider of 1 to 5 characteristic curve. 1 to 5 characteristic of the diode is given with the Ebers-Moll equation. Solid state physics amps is equal to amps output equal to energy volts over the time of the nth number of volts times temperature in minus -1, where room temperature of silicon is ampere hours over the 10 to the negative ampere n to the 2 and or voltage T of the millivolt. The equation is valid of the both forward and reverse bias region, but does not apply into the breakdown region. Real diodes generally exhibit a small deviation from this model. 2. Some applications diodes have many applications, however, there's few of them. Here are a few of them. Diode rectifiers. Half-wave rectifier. One of the most common use of diodes to rectify AC voltage DC power supply. Single diode can be only conducted current one way. The input voltage does negative with no current. The half-wave rectifier, Figure 5.4 on the right, show the input source of the diode and a resistor and voltage output ground. Full wave rectifier. Full wave rectifier is 4 diodes which can make up both halves or waves of positively coupled with the full wave rectifier diode bridge is shown in Figure 5.5 on the right. For both positive and negative swings input, the forward path through the diode bridge, while 2 of the diodes forward bias for the other 2 reverse bias. Effectively eliminated from the circuit, but both conducting paths current flow over the same direction through the load resistor, accomplishing full wave rectification. Full wave rectifiers are used in power supplies to convert AC voltage to DC voltage, or at least one for which are positive. A large capacitor in parallel with the output load resistor reduces a ripple from the rectification process. Figure 5 shows a full wave rectifier circuit. So the voltage outputs, the voltage inputs, and resistor in the middle. B. Frequency multipliers. A full wave rectifier frequency multiplier output rectified at 60 Hz signal is 120 Hz. It has components at 240 Hz, 360 Hz, are also shown in the figure below. And above the four carrier space representation, we include the zero frequency component of the DC bias in the plot. Filtering after full wave rectifier, you remove the unwanted harmonics. So over here we have 120, 240, 360 through 180. Frequency mixers. A full wave rectifier can also be used as a frequency mixer. Two frequency 1, and frequency 2 input simultaneously. Full wave rectifier output will include frequency the absolute value of frequency 1 minus frequency 2 and frequency 1 plus 2 in addition with the harmonics of 2 times frequency 1, 2 times frequency 2. Sign exercises, lab diodes. That was a quick talk about diodes, half bridges, half rectifier bridges, and DC currents.